Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 3 of the January daily LeetCode challenge, and we again have a medium question in front of us. And I'm damn sure, this is something that I'm damn sure that if you have been practicing coding for a long time, you will be able to appreciate your skills. That is how much ahead you are from the rest. Okay. Before starting this question, let me just show you one thing. Just here, after seeing this question, I will come to this part. See here, the acceptance rate is just 54%. That is, you can say that out of every 100 people, there are only 50 people who are able to solve this, and I will show you how much easy question it is. I'm damn sure if you have been watching my video at least last for 3 4 days question, if you have been doing sincerely, I'm sure that you will be able to do this question after some hints. Even like if you have been very consistent, you won't even require the hints. Just by seeing the solution, just by seeing the question, you will know that what concept you have to use. Okay, so let's begin this question. I will tell you all the approaches possible in this, and then I will show you the most optimal approaches in both Java and Python language. And Java, I will show you multiple easy ways to do it, because I will teach you also about the stream concept, and all those concepts also I will teach you with this question. Okay, before that, let us go through the question first. So it is question 2270, number of ways to split array. Okay, so don't worry when you see this particular topic, splitting of arrays and all that part, because many people feel very afraid when they see this kind of words in the question. But there's nothing like that. It's very very easy. I will tell you how. So if you see what you are given, you are just given a zero indexed array. Okay, here the elements can be positive and negative. So before going to the question, let me just show you the constraints first. Each element here, it can be up to the range of 10 power 5, positive and negative both. Okay, from minus 10 power 5 to positive 10 power 5. Okay, so this range is very big. So if you are planning to take, when you are, see, we have not seen the question till now, but just for your understanding, I'm telling you. So whenever you see these kind of limits, you'll have to first understand what data type you want to use to to go through each of the elements. Okay, int will not be sufficient for this. Okay, like we see, we'll come to the sum part also. We're going to take the sum of these. So when you're taking the sum, one thing is very clear, that if a single element is of this range, obviously int will not be enough to keep sum of all the elements. Okay, because the number of elements are also going to be up to 10 power 5. Okay, there's just one thing, that's why I'm showing you this before starting the question. Now let's come to the question. So only a num array is given to us, a integer array whose length can be up to 10 power 5, and each of the values can be from minus 10 power 5 to positive 10 power 5, right? And you have to just return an integer output. And let's see the question now. We are given a zero index integer array called nums of length n. Nums contain a valid split. Okay, nums contain a valid split at index I if the following conditions are true. Okay, what are this? They are saying the sum of first I plus 1 elements is greater than or equal to sum of the remaining elements. Okay, so see, I'm not reading this part because I don't want you to confuse the same. So they, what they're trying to tell you is this: see, these I plus 1 elements, and there are total n elements. Okay, so n minus, if you take the n minus open bracket I plus 1 close bracket, if you do, you'll get this number. Okay, n minus I minus 1. Okay, what they're trying to say is that the sum of first I plus 1 element is greater than or equal to remaining elements. You can just read it like that. Okay, no need to confuse yourself. They are just trying to confuse you in a way, but when you see the example, this part will be very clear to you. But just for understanding, I'm telling you, the sum of I plus 1 elements has to be greater than or equal to the remaining elements in the array. Okay, and remember, it's talking about the first I plus 1 elements. Okay, it's not about any I plus 1 elements. The first I plus 1 elements is greater than or equal to the remaining elements. This is the first condition. Next is, there is at least one element to the right of I. Okay, that is when they are seeing the remaining elements, when they talk about this part of the remaining elements, so you have to ensure that there is at least one element to remaining. Okay, as simple as that. So basically, like, by now you should have understood that we are talking about splitting the array into two halves. Okay, we are splitting the array into two halves. For example, if you see here, this is the maximum extent to which we can split. Okay, because after a minus 8, if you see, okay, let me zoom in. Yeah, after this part, see, this whole thing cannot be one. Okay, we have to split it into two parts, such that each of the part has at least one element. Okay, so we can start like this. We can start with 10. Okay, this, the left part is 10, the remaining elements are in the right part. Similarly, we can go to 10 and 4. Okay, similarly, we can go to 10 4 and minus 8. The 10 4 minus 8 forms the left part, and the right part is 7. So this is the max extent we can go. Okay, because they have mentioned it, there has to be at least one element in the other half. Okay, so this, till this point we can go, we cannot extend beyond this. Okay, this is the part, right? Return the number of valid splits in nums. Okay, we'll see examples now. So as you mentioned, as you can see that for this particular array, okay, so this is the maximum extent we can go. Okay, so there will be three splits possible. If so, just think it like that. If the length is n, there will be n minus 1 splits possible. Okay, so let's see each one of them. So what is the first split? First split is when you take 10 as the, in the left half, and the remaining elements in the right half. Okay, something like that. Okay, they mentioned the same. The first part is 10, and the second part is this part. Okay, take the sum. They are saying that the sum of the remaining part is, that is, the right part sum is 10, sum of the remaining part is 3. So they are claiming, since 10 is greater than 3, this will be a valid splitting. Okay, this will be valid splitting. So this splitting at index 0 is a valid. Now let's go to the second one. The second one is something like this. Okay, we're taking these two elements in our left part, and the remaining elements will be in the right part. Okay, so something like that. So yep, as you can see 10 and 4, and this here it will be minus 8 and 7. So if you now take this sum and see if this condition is being satisfied, we are talking about this condition. The sum of the left part has to be greater than equal to sum of the remaining elements. That is sum of the right part. Okay. So in this case, if you see 10 plus 4 is 14. Okay. And if you take the sum of this part, it is going to be minus 1. So definitely 14 is going to be greater than minus 1. For this reason also, this is a valid split. Now talking about the last split, something like this. Okay. This is going to be the first half, and this is going to be the second half. Okay. Now if you take the sum of the first half, it is going to be 10 plus 4, which is 14 minus 8. Okay. So it will be around, okay, 6 and in the right part we have 7. So 6 whether is greater than equal to 7, no, 6 is not greater than equal to 7. For that reason this split will not be a some what they're calling, okay, valid split. So this will not be valid split. Okay. So we have only two valid splits. Okay. The one at index 0 and the other reason is index 1. Okay. The one at index 2 is not a valid split. So for that reason, out of the three splits, only two are valid. For that reason the answer is going to be 2. Okay. So the hint for you is that whatever is the length of the nums, there will be n minus 1 splits possible, and among those possible splits we have to see which of them are going to be valid. Okay. Now how to solve this question? So if you have been following my video, or if you have been following the last few days of LeetCode, I'm damn sure that you will be knowing about what is a prefix sum. Okay. So in this question, what you can think of is you can take the prefix sum. See, I am not going to show this approach because I will be showing even a optimal approach than this. But just for your understanding, if you want to know some other ways to do the same, I'm just telling you a hint. You can look for prefix sum. How this prefix sum will help you see. The idea here is, for example, see, when I am at seal, this is some, let us say my it's going to be my left half, right? And we want to know the sum for the remaining elements. For this point, you can take prefix sum. So what it means is, for each index I should know what is the sum of the elements towards its right. Okay, something like that. Similarly, when let us say I am at this particular index, I need to know the sum of the elements towards its right. Okay, so this you can calculate using the prefix sum method. What is prefix sum and what is that? We have discussed this in the last 2 days question. I guess in the yesterday's question itself we have discussed this. Please go and check that video out. You will definitely get to know a lot about it. Okay. In, I guess, in day 2 video or something like that, I have shown you multiple approaches for similar questions. Okay. So please go and check that out. But the idea here is, if you solve using a prefix sum approach, it will take you off and space complexity. But we want to optimize even further. For that reason, the solution that I'm going to show you will be even further optimal. It will be just a constant space complexity. Okay. Let me show you my solution now. Okay. So how my solution is going to work? Before that, I'll just show the output for you to understand what it is. Okay. So if you see here, when we are at I equal to 0, okay, the first I plus 1 elements are this element. Okay. That is this element itself. Now, can you tell me why they are saying I plus 1 element? See, when I is 0, that is when we are in index 0. Okay. How many elements we have? We have only one element. That is why they're writing I plus 1. Okay. So don't confuse with what is I plus 1. I plus 1 simply means that with whichever index you are, take all the elements including that index and its left. That all the elements towards the left and the current index, that will be I plus 1. Okay. So when you're at index 0, you have at least one element, right? So that's what they're saying, I plus 1. Okay. So this is the element, right? So what is the sum? Sum is going to be 10. For the remaining element, the sum is going to be 3. So since for this reason 10 is greater than 3, so I equal to 0 is valid split. Okay. Now when we're at, this is the one, right? Index number 1. So what is the sum? 10 plus 4 is 14. What is the sum of the remaining elements? It is minus 1. For that reason, I equal to 1 is also valid split. Similarly, for I equal to 2, the sum is 6 for the left, and for the right it is 7. So 6 is not greater than equal to 7. For that reason, it is not a valid split. So the answer is going to be 2. Okay. So what idea that we are going to use is, before itself we will be calculating the total sum. So what is total sum? Total sum is equal to the sum of all the elements. Okay, as simple as that. Now I'm maintaining an element variable called current sum. Current sum will tell me for the current index in which I am. So including that index and all the elements towards the left, what is the sum going to be? Okay, so current sum is, if I am at index I, so including index I and all the elements towards its left, what is the sum? Okay, as simple as that. Then I'm also keeping answer variable. Yep. Then what we are doing, see here. First of all, we will include the current elements value to the current sum. Okay, current sum is equal to current sum plus 1. That is current sum plus nums of I. Okay, if you see, this is a shorthand. Okay, this is not a equal to operator, this is a shorthand. What it means, current sum is equal to current sum plus nums of I. This is the first part. Other than that, what we are doing now, remember, total sum includes every element. For that reason, I am going to subtract the current element from total sum. So if you see, what I'm going to do, total sum is equal to total sum minus nums of I. So with this, what we're trying to do, we are, see, after this operation, what will happen? After this operation, we are ensuring that the value remaining in the total sum doesn't include the current sum. Okay, that is, if we are at index I, after this operation, total sum will not have the the sum of current element I and any element towards its left. Okay, so for that reason, this, after this operation, total sum will be the sum of all the elements towards the right of I. Okay, its total sum will be the sum of all elements towards the right of I, and this will be sum of all the elements towards the left of I, including I. Okay, so for that reason, now we can compare these two. So what we are going to do, if current sum is greater than equal to total sum, then we have got a valid split. So answer is equal to answer plus 1. Okay, I will again repeat. Current sum means sum of all elements towards the left of I, including I. Okay, and similarly, total sum is actually sum of all elements towards the right of I, excluding I. Okay, excluding I, all the elements towards the right of I, excluding I. So for that reason, we are going to compare. If current sum is greater than equal to total sum, then we have got a valid split. Okay, answer. And one more thing, if you see here, I am going from I equal to 0 till n minus 2. Okay, from I equal to 0 till n minus 2. So if there are n elements, the last index is going to be n minus 1, and we are going till n minus 2. Okay, so whenever I write any value here, one minus than that will be the real value with till which we will go. Okay, so from 0 to n minus 2. So let me quickly run this and show you how it looks. As you can see, this is clearing all the test cases. If you want to segment the Python solution, comment this part out. Okay, let me do it the same. Just comment it out and then submit. Then you will see that this is getting accepted. Okay, the space complexity is going to be O of 1 because we are only using constants. Okay, that is, these are not dependent on n. Okay, when n increases, this will not be changing, as simple as that, right? And the time complexity is O of n because we are going through all the elements in this, and even in this we are going through all the elements. Okay, fine. Now coming to the Java solution, because many of you are interested in Java solution, so let me show you a Java solution now. See here, one thing that I want to tell you before itself is, in Python, if you see, we're using the sum function. Okay, now in Java, in order to do the same, okay, some people will ask me that why you are not trying this arrays.stream method. Okay, normally what people do, they will do like this. Okay, what I've shown you here, what they will do, okay, let me show the whole solution first, then we'll come to this part. Okay, so first I am declaring n, I'm capturing the length, then I am keeping a long. That's why I see mentioned in the starting of the question itself, based on the ranges you will have to decide on the data type. Okay, remember, you will not get an error that okay, your data type is overflowing or something like that, or even exceeding the limit, but you will get a, your answer will not be accepted. Okay, as simple as that. It will simply overflow but without a warning. So for that reason, you have to estimate that whether the sum that you're going to take will be overflowing the limit or not. For that reason, I've taken a long here. Okay, as simple as that. Initializing this with 0. And then what I'm doing, I'm going through every element and counting all that, adding all the elements to the total sum. So ultimately, after this operation, total sum is going to be the sum of all the elements. Okay, then I'm creating a current sum, then I'm creating answer. Then the same thing I'm doing, I'm going from 0 to n minus 2. Okay, I'm going from 0 to n minus 2. I'm increment, that is, I'm adding the current element to current sum. I'm subtracting the current element from total sum. Then I'm just checking whether the current sum is greater than or equal to total sum. Answer is equal to answer plus 1. Okay, then finally I'm writing the answer. Let me quickly run this and show you. This is clearing all the test cases. Even some of the edge test cases it is clearing. Like, you can submit this. I'm damn sure it will work. Okay, I've already done that and it got accepted. Okay, all the submissions got accepted. Now, coming to the most important part. What will happen when you try this? Why I have commented this part out? The idea here is, see here, as I mentioned, this is the integer array. Okay, nums is the integer array. Now when you do this part, what happens is that this will store the sum in a int variable. Okay, so see, although see, total sum is a long variable, that is fine, but when it is doing the internal part, right, it is storing in an int object. For that reason, when it is returning, you will not have the total sum if it exceeds the limit. No, you will not have the right answer, after this return. Okay, when this is returning, no, this will return the answer in an int limit. Okay, so if, let us say, the sum exceeds the int limit, then you will not have the right sum. Okay, for that is, even though it is long, it will not receive the right sum because the way it is internally, implemented, this will be storing the variables in an int. Okay, to overcome this part, first thing is you can do like this. Other thing is, what you can do is you can do like this. That's why I've created a separate solution to show the same. So this is how you can do. So after doing arrays.stream, then passing the, the integer array as the input, you can have this. Okay, as long stream. This will ensure that, okay, the variables are taken, because see, whatever is the data type of the integer, that is data type of the array, that will be used to store the values. Okay, now some also will be stored in that. So for that reason, when we're doing as long stream, what will happen is, while they are being evaluated, they will be treated as a long stream. Okay, that is a stream of long long variable data type variables, and then the sum that will happen will also be long. Okay, so the sum will be stored in a long variable and it will be written in a long form. Okay, and then you are doing the sum. So before doing the sum, you have to just ensure that you are calling this function, so that even if it exceeds the int limit, still you will be able to capture it. And when this returns the answer, this will be in a long format. So to ensure that the int, if it exceeds the int limit, the sum exceeds the int limit, still it doesn't overflow because it's in a long, okay, long data type. As simple as that. So you can try this. I have already tried this and it really worked. Okay, previous one, if you try like this, it will be failing in some of the test cases. Okay, but if you try like this will work. Okay? For that reason, on I have created this test case. This test case will tell you whether your solution is working for that part or not. This actually what will happen for this particular test case, it will be overflowing that limit. For that reason, I've created this test case. Maybe I can give this a test case also. You can try that out. Okay. So that's something that actually you can learn from this is how to use the arrays.stream. Okay, and some functions like this will be very handy when you are working in a real project, because these parts will matter most. Remember, in Java, what happens, you will not get warnings. Okay, some code compilers will give you warnings, but otherwise, let us say the lead code itself, it will not give you warning when the thing is overflowing, but you will simply get as your wrong answer. But the thing is, it is overflowing the limit. Okay, for that reason the answer is coming wrong. So yeah, fun, that was all for this video. This all solution I also having the same time complexity that of the Python solutions. Okay, that is O of n time complexity and O of n space complexity. So yeah, we started this question with discuss when I discussed the prefix sum approach. If you try the prefix sum approach, it will be O of n. Then I showed you the most optimal solution in which using a constant space complexity we are getting the answer. Okay, but we'll have to do two passes over the array. That is, one is to calculate the sum and the other one is for doing the final calculations. Okay, yeah. So yeah, and that was all for this video. I showed you both Python and Java solutions. And if you like my efforts, if you learn anything from my video, please subscribe to the channel. This really gives us a lot of motivation to continue further. We are just recently beginning 2025. Please have it as a habit, or please be consistent in coding. See, you will get results from coding only if you're consistent. If you're doing it for temporary purpose, or just for show off, you will not get the real fruit of it. I can say that from experience. If you want your life to be changed because of this, then please be consistent. I'm damn sure after some time you will see the result. Okay, how much you are different from other. That's why, before starting this question, I showed you this part, right? You can see here 54% of the people are not able to solve this kind of easy question. Okay, for whatever be the reasons, as I mentioned, like sometimes it will take int and it will overflowing, so that could be a reason why the solution did not work, or whatever it is. That's why if you are consistent, you will be very good. Okay, these small things will not be stopping you then. Okay, otherwise the small things will be roadblocker and you will not be able to submit the solution even when you know the concept. Okay, for that reason, please be consistent. This is it. I can say irony that such a simple question which is marked as medium but it is easy, still only 50% of the people are able to do it. So yep, that was all for today's video, friends. See you tomorrow. Thanks a lot.